All right. So, where were we? We have been talking about market failures. And now the particular market failures that are kind of most important when we are thinking about sustainability and environmental problems. We know that we've got these cool, in principle, these cool, markets, which are these decentralized things that come to equilibrium where supply meets demand. And we define supply as how much producers are willing to accept, and demand how much consumers are willing to pay. And so naturally you end up getting an agreement between producers and consumers, which we call the market equilibrium, where those two things equal each other. And in principle, in an ideal world, this agreement, this equilibrium, so that you get into an equilibrium, and I'll mark this as an equilibrium quantity, QM, and an equilibrium price. And so this is an equilibrium quantity and price. And in principle, this equilibrium quantity and price is a socially efficient allocation of goods to a society. That this is good for society where these things come out. But that really depends. So in order for this to be socially efficient, and we say socially efficient in the kind of Calder-Hicks sense, then that requires that the supply is going to equal to the societal marginal cost, and demand is equal to the societal marginal benefit. And so I guess I'll put this in a little box here, that's kind of our major requirement. And so when this does not happen, if not, then we have a so-called market failure. And so it is the failure of a market to do what it was promised to do, which is to find automatically in a self-organized way the socially efficient equilibrium. And so we said there are three conditions for efficient markets. And those three conditions, if we were to just name them, can somebody give me one of those conditions? You can do it in the chat or over the microphone, whatever you'd like.
Whether the market
complete. I heard complete and competitive. So I'll put those two things down here. I'll put competitive is the first one. And then there was this, I'll leave two, just to put these in the same order we did before. And then complete, that's one that was mentioned in the chat. And if I look up, and then information symmetry. So then there's got to be info symmetry. Great. And so we've talked, this is kind of the traditional one that you talk about in microeconomics courses. And this is, you've got to accept prices. So basically in a competitive market, when you can go to some other producer, then if that producer's price is too high, you can go to some other producer and take their price. And so if there are no other producers in the market, if it's a monopoly, then you can set your prices. So the cost, the marginal cost of the goods does not determine the price for you. So you just set the price at whatever you want, and then that allows you to kind of drive your producer surplus to whatever you want it to be. And so that would be, a non-competitive market. So in a competitive market, the price just is an output of the market, and you just got to accept what it is. And then, info symmetry, in this case, there are some environmental cases where info symmetry comes up, and this is when that buyers, so producers and consumers, I'll say, have the same access to info. And that's the same as this where the symmetry comes from. And so a plastic producer might know a lot more about the feasibility of recycling plastic than a plastic consumer. And they might even find ways to alter the, to make the plastic consumer think that plastic is more recyclable than it actually is. So, I'm sure you've picked up plastic bottles and you see the little recycling symbol with the number in it, and nobody knows what that number means. And they assume that that number might help you, sort these plastics out to make them more recyclable. But in reality, it's super difficult to sort plastics. And even when you can sort them out, it's super difficult to actually do anything with them. And so it's been a major problem that plastics are sort of viewed by the consumers as far more recyclable than they are by the producers. And so consumers think that there is a marginal cost and a marginal benefit that's maybe different than what the producers know. So that, and because of that, then you get a different type of decision making that goes on between those two. And so you may not get a socially equivalent or socially efficient outcome that comes out of that. And then the one that we are going to talk kind of the most about in this class, it's kind of the traditional Western philosophy on the economics of sustainability, is focusing on internalizing externalized things in these markets. And so completeness is this idea that that all costs and benefits are felt by the ones making decisions. It's probably not my most eloquent way of saying that, but it's the idea that if you're a decision maker, you realize all of the costs or all of the benefits in making your consumption decisions, or so if you increase the next marginal unit of the quantity that is being exchanged in the market, then we know where all those costs and benefits are. If you are causing costs or benefits to someone else, then your market might come to equilibrium, but the allocation of goods the allocation of costs and benefits basically that comes to the market will not be socially equivalent. And so we did kind of an example of that last time. So if we think about incomplete markets, and by incomplete, what we mean is that there is an externality.
I got a question real quick.
Yeah, go ahead.
I'm not sure if I remember or you said it before, but in order to reach a socially efficient market, do all three conditions have to be met, or just one of the conditions have to be met?
All three have to be met. Yeah,
Uh,
these are the three conditions that have to simultaneously be met.
okay, thank you.
Mm-hmm. So basically, if one of these conditions isn't met, there's an opportunity for the supply and demand equilibrium to become decoupled from social efficiency. So incomplete markets mean that there is an externality, and an externality can be positive, which is a benefit goes to someone not making a production or consumption decision. And this is primarily making a consumption decision. And then a negative externality is the same thing, but it's a cost that, same as above. And this usually applies to producers then. And so we did a little example last time where I said, okay, so let's see what the heck we mean by that. And if I were to draw a little axis here, as we usually do, where that's our quantity being exchanged. This axis has got dollars per unit quantity. And we've got our producer. This is our producer's private marginal cost, which is going to be equal to which is basically the supply. And so that's the marginal cost to the producer. For every unit they produce, this is how much they pay for that unit. Now the externality ends up showing up as damage that the producer is doing to some other party not involved in the production of that. And so that marginal damage curve looks just like the marginal cost curve, but it's separate from it. So this is our marginal damage, or MD curve, and this is basically our externality. It's our negative externality. And so consumers get thrown into this market, right? And they've got their own marginal benefit curves, which show up in this market as a demand curve. And so they've got their own demand curve here. So this is the demand or marginal benefit curve. And because the supply, so the market will come to equilibrium where the supply meets the demand. So that there is going to represent the market equilibrium, quantity supplied, and the market price. And so I could put little dots to connect those. Now the problem is that the actual cost paid to all of society, not just the cost paid to the producers, is greater than what is depicted by that private marginal cost. So what we're going to do is we're going to take that marginal damage and we're going to add it to the private marginal cost. And then that is going to give us this other line, which is going to be up here, which we made this really steep. So maybe that's a little steeper than I wanted to depict there. It's just going to be the sum of these two. So this here is our societal marginal cost, or the SMC. And I might write PMC down here just to remind us of the initialism. And that is going to be equal to the PMC plus the marginal damage. And so what we end up seeing here, so if I look back at this quantity that's being supplied, this is the cost that's that is coming just from the producer, but this cost down here, this is the cost to everyone else. So this is like, pollution, for example, or CO2 emission, etc. And so the total cost is going to be the sum of those two. And so the sum of those two is going to be here. And so this here is the total cost to society when you're at this market equilibrium. And so the market equilibrium, there's two costs being paid. There's the private cost, which is here. And you could say that this is sort of the public cost, which is the one that's down here. And when you add the two of them together, then you get this total cost that's up here. And so the stuff in between here, oh, it's maybe a little fatter than I wanted it to be. This stuff in between, that is the deadweight loss. And so if you kind of remember that, well, I guess I'll mention that in a second, but as as I'm about to sort of draw in this diagram, this is the point where we actually should be, but this is the point that we're down here. And when marginal benefit crosses marginal cost, then the area that is swept out to the right of that point is taken away from the benefits to the total social welfare. And so the area of this curve here is actually is reduced social welfare. So if you look at this triangle here, if you don't worry about the marginal damages, then this triangle here is what appears to be the benefit that's going to society in this triangle over here. That are all of the benefits that are going to society. But if you properly account for these marginal damages, for the externality, then you have to take that whole triangle and subtract away this triangle here, which are the deadweight losses. That is the losses from not operating at the socially efficient equilibrium. So just as an example, just to remind ourselves, deadweight loss is the term we use for the loss of social welfare when you're not at efficient, I'll say not at efficient equilibrium. So that's a loss. And so we would like to get rid of that deadweight loss. Well, how would you get rid of that deadweight loss? Well, you would say, well, if we actually made production or pricing decisions based on the real marginal cost to society, then we would be riding along this marginal cost curve, which would have meant that we would have instead found this equilibrium here. And that there is our socially efficient equilibrium, which I can call P star for the price half of that, and Q star for the quantity side of that. And so we can see that if we could manage to shift everyone so that they would be willing, so this right here will be a Cowder-Hicks improvement. So if we could manage to figure out a way to get the market to move its price from the PM price to the P star price, that's all we need to do. Is if we can get the market to raise its prices up exactly that amount, then the market will naturally snap into an equilibrium that will be socially efficient. And then that will fill out this. So if I was to highlight, so at the market equilibrium, we would have this producer or this consumer surplus. So this here is the consumer surplus at socially at efficient or at efficiency. And below that, this funnier shape, it starts looking like a triangle, but it actually is this kind of trapezoid here. This here is the producer surplus at efficiency. And so that funny shape together, that yellow portion and the orange portion added together, that is the maximal social welfare for all of society. That is where we should be to benefit. But if you forget about the deadweight losses, then producers are going to say, well, heck, if you base it on the cost of my balance sheet, this is an artificially high price, and that I should be able to lower my prices even more to allow people to buy more. And you're causing me to lose out, and the lost producer and consumer surplus is this region here. And so this is the apparent lost producer surplus and consumer surplus by operating at efficiency. But that's the whole point of an externality, is it's just apparently that way, because really what's happening is you're not, although you are avoiding the benefits of that kind of teal colored bluish area, you're also avoiding those deadweight losses. And the gray area is going to be larger than the blue area. And so it's better to avoid the deadweight losses, even though you're giving up some of that benefit. So that's the reason why it's a Cowder-Hicks improvement to actually move from this point down here up to this point. That is a Cowder-Hicks improvement, because the gray area you get rid of is larger than the blue area you get rid of. All right, so that is how we deal with a negative externality. This is how we model a negative externality. So what you should know for your homework and moving forward for things like an eventual midterm towards the end of the month is how to solve for all of these areas. And so you'll have practice on this on the homework. And then on Tuesday, again, I'm going to make Tuesday like a free class where we can just, work problems that I can actually put numbers into these things. And so that we can say, all right, if I give you these lines, can you find all the intersection points? And once you've found all the intersection points, can you calculate all the areas of these triangles, these squares, these trapezoids? So you can calculate, how much deadweight loss do we have when we're operating at the inefficient equilibrium, and so on and so forth. So are there questions about that? That was just review from last time. Okay, pretty clear. There's a lot of color on these graphs. They can be a lot to take in the first time you look at it. This particular graph is also discussed in your textbook. They don't go into as much detail on the mathematics there. Also in the notes that I've shared for this lecture online, I go into, I think I have a little bit nicer version of this where I've got some additional formulas and things that may help. All right, so that's a negative externality, how it generates deadweight loss. Well, what about positive externalities? That was a question from last time. And so in positive externalities, there are kind of two different things that we need to worry about and that we're going to focus on today. And those are public goods on one hand and open access or common pool resources on the other hand. So let's start with public goods. And all right, so let's move to the next page here. So the big topic this is under is, what about positive externalities? Because at first it seems like a positive externality. How could that possibly be a bad thing? A positive externality is someone else is getting a benefit from, I might have put effort into to some additional consumption and I got some benefit out of it, but just somebody else happens to get a little bit of benefit. It's a little bit parasitic, but it's not actually taking that much away from my benefit. So what's the harm? So that's kind of what we're going to be talking about here. And there are two cases that we're focusing on. And the first one will be public goods. And the second one will be open access or common pool resources. So that's where we're going. So, all right, public good. So what is a public good? So these are often summarized as goods that are shared by all but owned by no one. So the shared by all, that's the public part. Well, I guess the public part is also the owned by no one. So just in general, it's all public. It's looking about public good. Now, some examples of that. So, armed forces. So if you think about armed forces, then the consumption of armed forces, so consumption of this good is the same for all citizens. In fact, you don't even have to be a citizen. If you're in a country and that country is somehow being protected by armed forces, then even if you're not even a citizen, in that you're not even paying taxes or whatever, you're still benefiting there. So, and the benefit, and the kind of the key point here is the benefit to one person does not reduce the benefit to another. That's really the key point here. So if I'm being protected by the armed forces, you're being protected by the armed forces, and me being protected by the armed forces doesn't prevent the armed forces from also protecting you, at least in the abstract. Now, sure, if the two of us are in a room together and there's one soldier and they can protect either me or you, that's slightly different. That's a different problem. But if we're just talking about at the macro scale, you're talking about having armed forces in general, then I benefit from the armed forces as much as you do. So that's why we view it as a public good. And then other examples like biodiversity. And so biodiversity is that everyone enjoys the benefit, and the enjoyment does not decrease benefit to others. And so biodiversity, we know, is one of these environmental resources. We talked about natural resources versus environmental resources a couple of weeks ago. So we do view it as a good. You get more environment, you get more biodiversity, you get more good. But the benefits that I feel from biodiversity, let's say, crops are producing lots of food and everything like that. If we put effort into maintaining biodiversity, then the benefit that I feel from that biodiversity is not going to prevent you from also feeling benefit from the biodiversity. If you ramp up my benefit, it's going to ramp up your benefit. It's a public good. And there's lots of other examples of that for, you could say like, well, pollution abatement, that's another one. And so like in pollution abatement, then if we clean the air, then me feeling the benefits of clean air is not going to prevent you from also feeling the benefits of clean air. That's what makes it a public good. Anybody else think of any other public goods that they might want to share, either in the chat or over audio?
Would roads count?
I like roads. That's a good one. Thanks for that. So so roads or transportation infrastructure. And that is one where you could say, now we have to be careful about this one because we have to say, well, what exactly are we focusing on? Because you can have, if you talk about cars going onto the road, then the access to the roads is not a public good. That's a common pool resource, which we're about to talk about here in a few slides. But having the roads themselves, having the infrastructure available, that's similar to having the armed forces available. you know, that I am going to benefit from having an interstate highway system, and so are you. And the benefit that I feel from the interstate highway system does not affect the benefit that you feel from the interstate highway system. So having them available is, but we have to be a little bit careful about that, because when we actually start using them, so if in order for me to feel the benefit, I have to use the highway. Well, actually, the highway is something that as I use it, then I am taking up a little bit of room on that highway. So you have to sort of say, you know, but this, you know, to be careful, because use of a highway restricts other use, or, you know, well, you'll say other use. And so in this case, this will end up being what we call a common pool resource or an open access resource. So I think the general infrastructure is good, but then we have to be careful about this other thing here. So we're to focus on what we're talking about. Somebody else have any other examples they like to share that they think might be a public good? Okay. All right. Well, think about that, and let's, to maybe make that a little bit easier, let's then focus on, you know, more rigorously defining what we mean by a public good. And so a public good has two characteristics. Does anyone remember those two characteristics from the book, from this chapter, chapter 5?
Is it like non-rival and non-excludable?
That's right. That's what I'm looking for there. And that, I see that also in the non-exclusive one. So where there are these two axes that I'll draw here in sort of the next slide, rivalry and excludability. So for public goods, we say that a public good is non-rival. What do I mean by non-rival? Non-rival means that the amount of any individual's consumption does not diminish the amount available for others. So the amount of any individual consumption does not diminish amount available for others. And so that's what we mean by non-rival. So we aren't rivals for it. It's not like, in order for me to get access, you can't have access. So we aren't, you know, we both can share it, and it's fine. It doesn't matter if I'm using it or you're using it. There's always some of it. It's always available. Then the other part of it is non-excludable. And so non-excludable means that individuals cannot be prevented from enjoying the good. And so, you know, clean air is an example of that, where it's not like everyone who pays in to cleaning the air is going to be able to exclude people from enjoying the air who didn't pay into it, because the air, it's just impossible to do. The air is everywhere. Everybody shares in the air, and your enjoying of the clean air does not prevent me from enjoying the clean air, non-rival, and I cannot prevent you from enjoying the clean air, non-excludable. So those are the two important features of public goods. And so to make that a little bit clearer, we can sort of draw an axis, and they have a nice version of this in the book, where we can think about and I'm sure some of you have heard all this stuff in other sustainability classes, one of the biggest complaints we get about sustainability courses is the amount of overlap. I will try my best not to say the word ecological footprint in this course, because I know you've probably heard that a lot. And this is probably another one. You probably heard about public goods and common pool resources. On these axes here, we've got the kind of, I could either make this a degree of rivalry or a degree of non-rivalry. The book decided to make this x-axis non-rivalry. So you've got non-rivalrous over here and rivalrous over here. And then over here, I can make this non-excludability. And so you've got non-excludable up here and excludable down here. And so that basically divides this into these 4 parts. These 4 quadrants here. And public goods, pure public goods, are up in this top area. Because they have both of these properties. And so, you know, I think some examples from the book were like public Wi-Fi, clean air. You know, we've given some examples already. Public radio, I've mentioned before, etc. And then we are about to discuss as well this other, so this, I guess I'll, just to make it clear, circle that these here are pure public goods in this area. And then over here, there's also open access goods, which are also called common pool resources. And the key difference between them is that they are non-excludable, as public goods are, but they're rivalrous. And so a freeway, I would, you know, normally put over here. So the freeway itself is an example here, because now my enjoyment of the freeway is going to prevent, or is going to take a little bit of the freeway away for other people. And then a deep sea fishery, that's another example.
Are traffic signals counted as public goods, or pure public, or open access?
So that's an interesting question. I really like that question. I would say that a traffic signal, so this is sort of the, again, goes along with transportation infrastructure. The signal itself, I view, would be a public good, because my use, I benefit from the signal, you know, being able to coordinate, you know, red versus green, I benefit from that, and you benefit from that, and your benefit does not prevent me from benefiting from it. And me using the traffic signal doesn't prevent anyone else from getting access to it. I mean, so technically, yeah, if I'm not at the traffic signal yet, I can't use it because I'm waiting in line. But if I'm waiting in line, I don't really need the traffic signal. So to me, I would say, yeah, like traffic signals, or, you know, anything that coordinates people in that sort of way would be a public good, a pure public good. I think that's an excellent example, an interesting example. But like a deep sea fishery is not, because the deep sea is important because it's still non-excludable. So anybody can go into the deep sea and fish. So I haven't privatized that fishery. But as more people fish there become less fish available for other people to fish. So that's why it is rivalrous. So open access goods are rivalrous, per public goods are non-rivalrous. That's kind of the big thing. And then if you want, you know, other examples, we can also talk about pure private goods. It's meant to be a P. And that's like a candy bar, shoes, So an example of a pure private good is something where if I buy the candy bar, it's mine. I'm the only one that gets to eat it. And so you can't eat it. You can't even have any access to it. And my enjoyment of the candy bar will definitely prevent your enjoyment of the candy bar. Candy bar is a private good. It's something I own. Shoes, same sort of thing. But then there's this weird group of club goods. But club goods end up being help us solve some problems with open access and maybe public goods as well. And so these are things like private Wi-Fi. And you know, maybe cable TV or satellite radio. So these are like, once you've paid in to the club, then everyone in the club, it's almost like they're a public good. So like Wi-Fi, like, you know, if, you know, private Wi-Fi, public Wi-Fi might be bad because, you know, so public Wi-Fi, depending on how well it's implemented, starts becoming more like an open access resource. So like public Wi-Fi here could be in either one of these places, because if a lot of people use public Wi-Fi, then the Wi-Fi can get slower and slower. But private Wi-Fi helps prevent that, because you could say, all right, you pay into it, then anybody who pays into it, I don't care who uses it. And I'm going to engineer things so that member use doesn't reduce the benefit that other members use, but you got to pay into the club in order to have access to it. And likewise, cable TV, car sharing services, they list in here, I think in the book, maybe. So this is, you know, anything where you kind of join a club to get access to something, that gives you a little bit more control to prevent some of the problems with the externalities. It helps to internalize some of those benefits so that the people receiving the benefits are actually paying for those benefits, and that's the internality. So that's why club goods end up being a really important solution. And there are things like toll roads, which are kind of similar to that, where this is something that you pay to access the toll road. You're not like becoming member of a club, but you still, once you're in the system, you're kind of temporarily a member of that club. So, you know, toll roads are kind of often grouped here in this kind of club goods as well. So, all right, so this is kind of our categories here. So before we now go on to how we model this in the kind of market framework, are there any questions about these characteristics, rivalrous, non-rivalrous, and excludable versus non-excludable? Does this make sense of how you might categorize these things? And of course, there are fuzzy things that might live on the edge. And like I mentioned, public Wi-Fi is an excellent example where under most operating conditions, it's a public good, but when it becomes close to capacity, it becomes an open access resource. And so that's something where there are a couple things where it's a little hard to figure out what bin it's in.
If there are certain things on the grid that could possibly be two of the options, will we just pick the one that happens, that, like, how do you say that, mostly occurs? Like public Wi-Fi, would it just mostly occur in pure public goods then? Would it just stay there for most of the time?
Well, what I would say is, so there's kind of two levels of that question. For like assessment in this class, I will do my darndest to disambiguate anything, so that like if I said public Wi-Fi on a midterm, I might say, you know, public Wi-Fi where the amount of bandwidth available far exceeds the possible needs of the public, or something like that. And if I've gone through the great effort of adding that qualifier, it's pretty clear what I'm talking about. That thing is a public good. Now, in practice, these categories are meant to be models to help economists think about potential problems. And so you say, to what degree is this good a public good? And if it is primarily can be viewed as a public good in this context, we now can look into the great literature on all of the potential problems of public goods and try to find solutions that that relate to that. So you should view yourself, if you're ever doing economic analysis, as a little bit like a doctor who's looking at symptoms and trying to come up with potential solutions to those symptoms. And so you say, all right, given that you've got these couple of different symptoms, I would put you in the group of, do you have the flu or do you have COVID-19? Totally different treatment regimes for those two things. And so you have to say, well, this is looking more flu-like. I'm not quite sure if they have the flu, but it's looking more flu-like. And so I'm going to apply a flu treatment. And then hopefully that fixes the problem. So an economist would apply interventions that are designed for open access resources. And if those don't work, then they might then think, well, did I think about this wrong? It turns out this is a public good, and so it requires a different set of interventions. So this is just providing you a lens on which to look at these potential problems, all that kind of relate to positive externalities.
Okay, so
Does that help?
Yeah, so it just pretty much depends on the situation then.
That's right, that's right.
Okay.
And so what you should become skilled at is trying to look for these characteristics in each one of your these situations to say how non-rivalrous are things, how non-excludable are things. And then hopefully it'll be clear that this is super non-excludable, super non-rivalrous, definitely a public good. But of course, when things get a little blurrier down here, it's going to take more creative solutions. And sometimes there's a hammer that really fits every nail, and you can say, well, I'm not quite sure I need it, but I am going to implement a club approach. So I'm just going to make everybody subscribers. And then that way, I'm not worried about this positive externality. I'm just going to internalize this positive externality and, and make it a club good. So, or maybe I need to add advertising. So, I'm not quite sure I'm going to have the big problems with this public stuff here. So maybe I'm going to add advertising, and that kind of shifts them closer to these club goods. And so it's sort of like the externalities are the positive externalities are the biggest problem up here. And your job as a policymaker is to decide how important it is to shift things down into the club area or the private area. And there's a number of different ways to do that. And so hopefully that'll become more concrete as we move forward. All right, so now we're focusing for now on public goods, and then we'll shift to open access, and that will be the end of the lecture for today. So these public goods, as we'll see here, the big problem is undersupply. Of the good. So basically, the big problem with people benefiting from something that you invested in is that that thing that clearly benefits both of you could be supplied more to both of you if both would pay into it. And so that's what we need to kind of model here. And so how do we do that? So if we go back to this kind of market diagram that we've been working on, so we got our axes here. Sorry, let's make that a little cleaner looking. And we've got our quantity of the good that is exchanged in society and our price per unit quantity. And we're not going to worry about negative externalities. So I've just got one marginal cost here. That's our marginal cost. And supply. Then the marginal benefit, that's where things get interesting because we have a positive externality, because there's benefit that is going to be from, there's two different types of consumers. There's the consumers that have kind of different benefit curves. And so I'm going to write two marginal benefit curves here. So I'll put marginal benefit A, and I will then also put a marginal benefit B down here. And hopefully I've got these shapes. So this is marginal benefit A, And down here, this is marginal benefit B. So that's this line, and then the A is this curve right here. And so we've got, I'm going to just write that out here. So this is the MBA is the marginal benefit to consumer A, and MBB, marginal benefit to consumer B. Okay, now what's the difference between these two? Well, A once is willing to pay more than B, and that's kind of the critical difference here, but both consumers benefit. So if we look at this, we say if consumer, you could say imagine that consumer B does not exist. Then what we find is that then in that case, we have, supply, is just equal to NBA, and that will be the socially efficient equilibrium, and that will end up showing up here. And so this ends up being the market equilibrium. This is how much is going to be supplied. And this here is the price at the market equilibrium that is being charged for that good. Now, for the amount of good that is available in the market, notice that consumer B would not be willing to pay for this good. So, so this is, this here is basically the equilibrium depends only on marginal benefit A. And down here, we see that consumer B is unwilling to pay for QM at PM. So the price of the good is above the price that consumer B is willing to pay. And so consumer B is not going to pay. They're not willing to pay. They're not going to pay, but they're going to benefit. So they will benefit even though they're not paying. Who's paying? Consumer A. Consumer A is paying for the benefit to both consumer A and B together. That's what's going on right here. So what should have happened if this was an efficient equilibrium? Well, and I'll redraw this, but the basic idea here is that these two benefit curves really should be added together so that there's a market benefit curve that is going to look like A's curve up to this point right here, and then we'll add in B's curve. And then that combination of the two, and I'm going to redraw this, but I'm just kind of showing you where this meets in our graph, that would end up shifting the equilibrium up to this point here, which would increase the quantity supplied and also would increase the price. And so both consumers and producers would benefit if consumer B would just pay for the benefits that it's enjoying. So how do we model that? So we go we're going to take that same curve, trying to decide here if I want to copy and paste this thing, and maybe I do. So what I'm going to do is I'm just going to try to copy and paste as much of this as I can and see how this is going to look. And I might have to erase some stuff here on this other sheet. If I was a smarter instructor, I probably would have made space for both of these, and I apologize for that. So this is the same plot from before, but I'm going to erase some of my annotations here just to make some room. And so while I'm doing that, you can feel free to redraw this if you feel like that would be useful. All right, so I have erased this stuff. Well, all right, you get the point. And so what I want to do is then draw a, maybe in gray. I'm going to find this point here. This is the point where consumer B starts getting interested in the product. So above this point here, when there's more than this amount for this point on, then B has no interest in paying. So once the market is flooded with this amount on, then B just totally drops out. But, or they're just enjoying it, but they don't, every marginal unit is not worth anything to them. So they're definitely not willing to pay. But for these quantities over here, then B is willing to pay. So I could say, well, what if I could manage to get B to pay for this? Well, then I would end up adding this green curve on top of this blue curve. And so I end up getting a, well, yeah, okay, this is what I'll do. I end up getting a curve that is the superposition of those two curves right here. And so I'll just kind of maybe draw a thick gray line down here. And then maybe I'll highlight this just to really drive it home what the heck's going on here. Maybe that, I'll make a slightly different color of gray, maybe a darker gray. And so if I highlight that, then I have just drawn on this curve. But turn off the straight line. And then that curve right there, that is marginal benefit A plus marginal benefit B. And this here is the societal marginal benefit curve. This is actually the benefit that is really truly experienced. So at QM from before, we had the benefit that A was getting plus the benefit that B was getting. And so we're just taking this little bit of benefit here and adding it up there. So that is what gets added right there. So this here is the total benefit at the market equilibrium. So if supply was equal, or if demand was equal to this, then the efficient equilibrium would be right here. So that right there, that here is Q star P star. And so that's the efficient equilibrium if the societal marginal benefit was equal to the marginal benefit A plus the marginal benefit B. And so we can see from there that Q star and P star we get a shift up. So we get Q star is greater than QM, so more produced. And we see that P star is greater than PM, so you get more benefit to producers. And so that, diagrams, and so the deadweight loss that we're losing here is, trying to do this without being quite so ugly here, is that we see that the producer up here, this funny shaped non-triangular thing, that thing there, that trapezoid, that is the consumer surplus at the market equilibrium. And then down here, this is the producer surplus at the market equilibrium. So I could write those in, that this is consumer surplus at QM. This here is producer surplus at QM. And then as you can see, there is a region which I can highlight in orange out here. And that orange region there, that here is the deadweight loss at the market equilibrium. So that little triangle is the net benefit to society that we're losing. And so producers would actually benefit more and consumers would benefit more if we could somehow account for the marginal benefits. And as you know, with some things that are just naturally public, like public radio, it's going to be really difficult to do that. I mean, all you can do is run pledge drives periodically and just hope that the people out there that are listening to public radio but are not pledging will get so annoyed with those pledge drives that they will pay to stop the pledge drives. And so that is one way to try to internalize the decision making for those people who are benefiting, so that they'll start coughing up money that compensates, and that's why in public radio they say, we don't care how much you pledge, just pledge something. That's them saying this down here. They're saying that we know that some of you have higher marginal benefit curves than others, but for the amount that we are providing, some of you are getting this benefit and some of you are getting this benefit, and we are just asking you to pledge based on how much you benefit from this. And this really shows that they mean that. Like, they don't care whether you donate $5 or $500. Because if everyone would donate, regardless of how much they donate, you don't have everyone to have to donate the same amount. You end up still getting a total benefit that's higher, and that will allow them, through market pressures, to provide better content. So if you don't like hearing quite so much jazz at night and you'd like to hear, some more expensive content that they could subscribe to from, other public radio sources, then, you can get rid of that local jazz station, and instead they'll use that money to pay for, a more highly produced, program that doesn't play the same 5 jazz songs over and over again, just as an example. So, so that's kind of, how we capture that. And if you can make it not a public good, but making it a club good, then you solve this problem. If you can really, satellite radio solve that problem. They actually are able to say the only people to listen to satellite radio are the people who subscribe. And then that internalizes things and allows them to fill out this triangle.
I got a quick question for the quantity-based stuff on the graph.
Yes.
On the bottom part, that you wrote in gray, as a B has no interest in paying, what direction is that? Anything on the right side, to the right of marginal benefit for B?
Right. So, and I'm sorry I wasn't more clear, but I can say B has no interest in paying after Q is greater than this point.
Okay, thank you.
So, yeah. Any other questions about this diagram? Okay.
These are gonna be posted, right?
Yeah, it's already posted. So
okay.
the formal notes that I'm looking at over here on this side of my screen are online. You can take a look at that. This will also be posted. These are kind of the scratch notes that I'm doing here. Okay. And then this is also in the book. All right, so that's those are public goods. And the other ones that I want to, in the last 10 minutes here, I want to talk about, which will not involve another one of these diagrams exactly, but these are the open access resources. Or open access goods, which of them, their common pool resources fall into this group. And this is another case of externalities. And so the 2 conditions for open access resources and the access to the resource is unrestricted. And so this fits the non-excludable part. And then 2, and this is the key difference from public goods, it has diminishing marginal returns. And so this is the part where this is where it is, it's not non-rival. So we could say this is rivalrous, or if you prefer, we can say it's not non-rival, if you like the double negative here. So as more use the resource, then benefits to others increase at a slower rate. And so, and it's this decrease in marginal benefits that is ignored by the decision maker. So you are, so I guess before I say that, I'll say that the key point here is that these are rivalrous, non-excludable, and in the specific case of what I'm about to talk about here, they're also what we're going to call subtractable. And so this here defines the so-called tragedy of the commons. Is when we've got this rivalrous, non-excludable, subtractable resource. So there, so I guess I could say that there may be a critical point beyond which the resource cannot provide any future benefits. You know, in the future, if enough people use it, then this thing will stop providing benefits. But the present benefits to individuals are, and the unrealized costs are going to lead to overuse. And so there may be a point where continued use cannot provide future benefits. Let me just see if I can do continuous scrolling. No, it doesn't look like it. But the present benefits and the unrealized costs lead to overuse. So, you know, examples of this, again, I'm sure that we've heard about many of these examples, so I'm just pausing here to give people a chance to catch up. But you know, common examples are like, and I'll write these down on the slide here, but common examples are a fishery, for example. So in lecture D2, we'll talk about fisheries and maximum sustainable yields. So fisheries are an excellent example where if it's non-excludable, it is definitely rivalrous because people who fish out of it, they are subtracting benefits from others. So somebody, the first person that comes can get a lot of fish. The second person that comes can still get a decent amount of fish, just not as many fish as the first person experienced when they came and they were all alone. The third person is not doing as well as the first or second person, but they still are doing a lot better than they did before they entered the fishery. And so this thing where every new person is doing better going to the fishery than they did not going to the fishery, but eventually leads to so many people fishing the fishery that the marginal benefits at equilibrium are going to be the same as if you had gotten your fish from somewhere outside of the fishery. So, so that's the, you know, I'll just mention that example here. And I think I'm one generating that audio issue. Let me. All right, cool, that fixed that. All right, so the example that I just gave was fishery, not a private fishery. So, and then the so-called maximum sustainable yield. And we will talk about that in detail in lecture D in the next unit 2. That's an example of a renewable resource, at least so long as you stay under the maximum sustainable yield. So that's unit D is where we're all talking about those types of resources. And then the other example is freeway at rush hour. And this is sometimes easier to explain because if you think about a freeway at rush hour, it is as slow as the side streets. So this can be traffic is as slow as side streets. And that is because the first car on the freeway was able to travel faster than on side streets. But reduced, speed of any existing pre-rush hour traffic or non-rush hour traffic. And then more so for second car. And this goes on and on and on until eventually there's some critical car. So we'll say the nth car enters expecting it to be faster, but moves at same speed. So that is an example where you cannot exclude people from entering the freeway, but every time they enter the freeway, they slow it down for everyone else that's on the freeway. And so I'll pick up here, the stuff that I didn't quite finish here, we'll pick up next time because we're at time, but we're basically at the end of the lecture anyway, but I just want to at least throw out this term, collective action problem, that these particular tragedies of the commons are collective action problems, and that they can really only be solved if they can be solved at a global level. And this is why very frequently it invites regulation. And so we can pick up where we left off here next time. By next time, I guess probably the Thursday, because I said Tuesday, we'll just kind of do an optional, like let's work some numerical examples out. We'll be in it, but I want to at least mention the prisoner's dilemma, which again, I'll then just, if it's not already in the next lecture, I'll just tuck it in at the beginning of the next lecture to make sure we cover this. All right, so that's all I've got today. So let's do the attendance exercise. So I'll put the link there. And so the question for today is, what is the key difference, preferably in econ terms, between a public good and an open access good? So that is our attendance question for the day. And otherwise, that's all I got for you. So if you don't have any questions for me, you can feel free to hop off. Otherwise, I can stick around for a few minutes and field some questions. Again, remember, Tuesday is just an optional lecture, no attendance, where we can work some problems if you'd like.
Thank you. Have a good weekend.
Yeah, you too.
Thank you.
Mm-hmm.
Thank you.
So super quick clarification question. On Tuesday, it's the optional lecture. So we're not required to be there because it's the fall break chaos, but then Thursday, we're back to normal.
Thursday back to normal, as if it was coming out of fall break.
Okay, sounds good. Thank you so much.
Yep.
Have a great weekend.
Just making sure that this coming Tuesday's lecture or optional lecture is we're gonna be working problems similar to the homework assignment as like practice and
We
stuff.
can. I mean, I'm not going to prepare anything specific, but I'm happy to say like, all right, here's a supply function, here's a demand function. Let's plot those out. Let's do some solutions. Let's set things equal to each other, solve for some areas. So yeah, we can do problems that are very similar to the homework. And you know, the homework doesn't do this public good one, and we can work a public good one because you might see that on a midterm.
Okay, I'm just like probably get started on the homework, and if I have any questions, I can ask for examples of the specific to the homework. All right.
Yep.
Thank you so
that
much.
sounds good. Yep.
All right, you have a good rest of your weekends.
You too. All right. Looks like we're at an anti-quorum, so in the meeting. And again, have a good weekend.